I'd like to thank Total Element Magnet Supplier for sponsoring this video. These guys are at least 10% less than the other big name magnet providers. And if you use the link in the description and the code 3DPPM, you'll get an additional 10% off your magnet purchase, as well as any magnet accessories like the magnet splitter I'm going to be showing in this video. Again, I'd like to thank Total Element for sponsoring this video. All right, guys, so welcome back. So I created a new rotor. This one has 6 1-inch by 3/4 inch barrel N52 barrel magnets in it. And it's made of, this is just made of regular PLA. I didn't use the PET G. And of course, the top one, if you guys should recognize, is my PCB way rotor, which I love, made out of the clear acrylic that they print, I think, in SLS. And this is that fat rotor. That fat coil that I love, that produces a lot of output. 8 volts coming in. It induces current in the second coil, which comes out here, and also the magnets induce current. And it gets it doubles it up, and it comes over here onto this meter. All right there. Where am I? Right there. Oh, wait a minute. What the hell is that light doing on? There we go. Hopefully that's not going to be too bright. Anyway, yeah, so I think by itself, if it didn't have current already coming into it, and then the current that's being produced by the magnetic flux on the coil, I don't think it would produce as much output as it does. But regardless, it does. So let me get it the rest of the way set up, and I'll bring you guys back. Stay tuned. All right, guys, so I printed this new rotor, which came out fantastic. And again, this is my maglev. I printed this out with the new A1. And I got to tell you, the A1 compared to the Ender 3V2, even though I still love the Ender, the A1 prints an hour faster. Even with the settings that I have for the Ender 3, and I have the FF settings from Chuck, the fast settings, which makes the Ender 3 really fast and still high quality. The A1, there's just no comparison. Anyway, I printed out this new guy here, and of course I have one of my favorite PCB way rotors. And I'll get this guy going in a second, but what I wanted to show you was this. This comes from Total Element, the sponsor of this video. And I got to be honest, when I first looked at this thing on the website, I thought, it looks like a cheap piece of wood. It is not. It is really sturdy. It's really tight. It has metal plates on the bottom, so that when you separate the magnet, when you use this, I can't do this with one hand, separate the magnet, it'll fall and stick to the bottom there. It won't try to shoot back up and re-stick again. Let me get my camera in a stand, and I can show you how this thing works. But you can see this is really nice quality. It smells great too. I don't know what kind of wood it is. It looks like it's oak, and oak is pretty hard. But you can see, or you can actually hear how tight it is. And it's a decent weight too. I actually thought, like I said, I thought it would be kind of cheap, but pictures never paint the whole story. But yeah, Total Element sent this to me. Thank you, guys. This thing is freaking great. No more am I going to slam my fingers up. Let me get my camera in a stand so I can show you how this thing works. Stay tuned. All right, so let me give you a better, closer look at this. So as you can see, the magnets are stuck there because they put 2 metal plates in the bottom there. And it was funny because when I first saw this thing on the website, on the Total Element website, I looked at it and the first thing I thought was, it looks a little cheap, and I'm going to put some metal plates on the bottom there so that when I separate the magnets, it'll catch it. When I got it, it's not cheap at all. This thing is heavy duty, and there's already metal plates there, so they already thought about that. But yeah, it's nice. I think it's made of oak. It's pretty heavy duty. Let me show you what it looks like when you separate them. See, the magnet drops down, sticks to the base there. So it works really, really well. And again, they've got it on their website along with a few other magnet accessories like pole finders and everything. But this thing is reasonably priced. It's well built, and it's definitely worth a look anyway. Nice big carriage bolt in there, nice and tight. Yeah, Total Element. Check it out, guys. All right, guys, so let me show you what I got here. Let's pop this guy on. That's 8 volts coming in. Come on. It broke. Dang-nabbit. So it's 8 volts coming in and going through this coil, which is a dual coil. There's a run and there's a pickup on the other side, which is going to this bridge rectifier, and it's pissing out 101 volts. I really gotta... Yeah, it's popping out 101 volts. What I want to do is, I want to see if I can take the output from this guy. I'm going to have to fix this. Let me shut this off. Yeah, I'm going to have to fix that. Too much vibration. And again, this is floating. You can see, I don't know if you can see that. I have 2 magnets down here, so this is floating in between. So it's kind of a maglev, although there is friction on these bearings here. What I want to do is, I want to hook up another circuit and another rotor inside this guy here and see if I can't run this second. I think I can do it with the low voltage circuit I have. Run the second one off of that. So running one pulse motor off of another pulse motor. I'm probably going to take this guy off the top here because it's really not doing anything except adding weight and probably helping to cause the vibration. So stay tuned. All right, so here's the rotor I'm going to run in this one. I just printed this on my Bamboo Labs. Oh, I got to straighten these out. On my Bamboo Lab A1. This is made with PETG or PETG. So this is nice and sturdy, and it's going to sit. It's going to sit, oops, inside this guy like this. So we'll see how that works out. I've got to fix those though. I thought I could push them all the way in, but I can't because they interfere with each other. So stay tuned. All right, so I got this guy in there, and there's a ball bit. So this is a solid carbon rod, or not carbon, fiberglass, whatever you want to call it, rod. And there's a ball bearing in the bottom of that stand there, so it spins really freely. And it's on bearings as well, so I can hold it tight, and it will just spin off of the bearings that are here, but it'll also spin on there, which is the sound you're hearing. So now let me get a coil set up and see what I can go from here. Oops. Yeah, let me see if I can run this guy off of this guy. Stay tuned. All right, so I got it set up, and I'm using one of Sky's coils. This is the very first coil I got from Sky Collection, it's an awesome coil. You can probably see, if I pull it out, you can see how it's wound, perfectly wound. And he taught me how to wind coils and how to put paper or plastic spacers in between each layer, which makes it a lot easier to wind. I'm going to run this guy. I've got it coming right now into the meter. I'm going to run a couple of leads off of that into this circuit here, which is just a regular dual JL94 circuit, and see if we can get this guy to run off of the output of this bigger one here. Let's see what happens. Something just popped over here. I don't know what it was, because this guy's running fine. Yeah, something popped on this circuit, and I don't know why it would have. I don't have anything shorted out. Oh, wait a minute. Hold on, let me bring you guys back. There it goes. All right, so this guy's running 8 volts coming in, and it's running this little guy here. So one pulse motor running another pulse motor. It's only 8 volts coming in. Oh, that's what's wrong here. Hold on. All right, hold on. All right, the bearing had popped out. Yeah, so it's running 8 volts coming in here. Running this guy pretty good, too. I'm surprised. I didn't think it was going to run it that well. I think what happened was I shorted out this light back here, which is running off of this circuit here. And I think it's getting too hot. But it is running. All right, let me check something out. Stay tuned. All right, it's a real mess back here. I really got to straighten out my wiring and stuff. Yeah, so what happened was, where is it? This light that I made the housing for, I 3D printed it, it's kind of cool, was the output of this circuit right here, which is this right here. Went to that. The leads crossed, I think, and there was a little spark. But that shouldn't have sparked, though, so I don't think it came from that. I don't know where it came from. There was a little spark, though. Let me hook up this output here to the meter and see what's going on. Stay tuned. Yeah, so I think I hosed something on this circuit, because normally I should be getting more than 3.94 volts out of this output here. Let me try turning it up a little bit and see what happens. Whoop. Let me turn that down just a little bit. All right, there's 11 volts. Yeah, I think I did something to this circuit back here. Dag nabbit. I don't know if you guys can see it. This one right here. But it's working. I have one pulse motor operating another pulse motor. Oh, I'm going to start wearing white gloves too, because no one wants to see my arthritic hands. Yeah, it's running. That's a nice little rotor too. 5 volts are coming off of this extra one here, so I could, in theory, feed it into this guy here, but I don't want to do that. So the output from this bridge rectifier right here is going into this circuit, which is running this coil, which is running that rotor. Kind of cool. I wonder if I can triple it. Have this one run this one, and then I have the output. I'll have to get a different circuit from this one here. And I could probably use the low voltage circuit that I have and run like this guy on there. I love this coil. It's a great coil. All right. Mission accomplished. Stay tuned. Whew. I didn't blow the circuit. I just blew the light. Because now I have a light attached to the output of that circuit. You guys can't see it. That circuit right here. This is a dual JL94 circuit. So the output, which is this peg right here, is going to that light that you can see flashing. For you guys it's flashing, for me it's solid. I was worried because I wasn't getting any output on the neon bulbs, but I'm not going to get any output as long as there's output coming out of here. So I didn't blow the circuit, thank God. I should have though. What a mess back there. Alright guys, thanks for watching. Alright, so the next thing I'm going to embark on is winding a coil. I think I made this coil on my ender. Yeah. Which it's freaking good for. And this is made out of, oh yeah, this is made out of that iron infused PLA. Just want to see. So I'm going to make it a bifilar coil. And I got 20 and 28 gauge. So there's a big difference. I may go from 20 to 23 gauge. I don't really know. But yeah, and I'm going to use this guy to print out the strips that are going to go between each layer, which makes it a lot easier to wind. I may go with this. I don't know if this is 28 or 23. Let me see what it is. Oh yeah, this is 23 and this is 20. So not that big of a difference. Yeah. I had the 28 on there and I didn't want to go that big of a difference. So 20 and 23. So I'm going to get winding. You know, now that I think about it, when I printed out that black iron infused PLA, I used the temperature that wasn't high enough. And so the coil itself is a little bit brittle. All right, so here's the one I was talking about. And I don't know if you can hear that, but when I pinch it, it crinkles a little bit. And it's because I didn't print it at a high enough temperature. But now that I got these two halves glued together, I think it'll be okay. And the glue I use is acrylic number 16. It works really good with 3D printing parts, at least with PLA and the other ones that I use. I'm still going to print out another one out of the PET G. I got some glue on there. Dagnabbit. But I think I'm going to still try and do this one. All right, so wish me luck. Ciao, guys.